All right, guys, welcome to the live stream, the Scalefree live stream for the AI-powered business. My name is Michael Olschimke. I'm the CEO of Scalefree, or one of the CEOs of Scalefree. And yeah, it's really, today's session is again, just like last week's, about my thoughts, what I've done this week, or what my task this week essentially, and how was my, where I've spent my time essentially, right? So, and yeah, just like last week, we focus on essentially two aspects here, on data and AI. So left side here on the screen, you see the data topics here more or less, and on the right side, you see the AI topics. I will jump back and forth a bit. So you see on numbering here, I'll go in a time circle, right? So clockwise. And yeah, that's the idea. So let's start with the first topic here. There will be no guest, by the way. So we'll have once in a while guests. This time not no one, but next week hopefully another one. So we'll see. So I had an interesting customer engagement because it was some session with a customer where they essentially start modeling a data vault, and they process a lot of real-time messages. What they receive is essentially Kafka messages from a source system. The messages were CDC. More or less, they didn't use a CDC approach, or CDC tool, but in essence, it was my impression at least that it was very similar to CDC. So they received inserts, deletes, updates essentially from the source as individual messages. They could distinguish those, so it's very close to CDC approaches. And what I see a lot is that many customers, many clients, they put a lot of effort into modeling these messages. An obvious approach would be to model this data as let's say you get account data, for example. That was one of the topics there. Let's say you get account data, like a organization, right? So you have some business key that identifies the organization, and you have some descriptive data, the account name, the location, and so on. So obviously, if you think about this in batch loading, you would model this as a hub for the account number, and then some satellite to keep track of the changes to the descriptive data. That's the most obvious design model. But then you have a hard time, to be honest, to capture this data in real time. Now think about this. First of all, you receive CDC data. No matter how you receive it, it's CDC data. If it comes via real-time messages via Kafka, or if it comes via near real-time batches in near real-time via Spark or something, or Spark, for example, and it's offloaded into a data lake, it's still CDC data. And to capture CDC data, we typically use a slightly modified design. First of all, we don't do a delta check on the satellites. Think about this, just argument-wise. The delta check in a satellite, the purpose of that is that it should reduce the storage consumption of a satellite when you deal with, let's say, full loads. Let's say you get full loads every day in your staging area or data lake. You receive those full loads every day. You can't just offload or load everything into the satellite without removing these non-deltas. That's why we have the delta check there, to remove the non-deltas from your load and reduce the storage consumption of your satellites roughly, because that will speed up. It will on one hand be help you to cheaper save the storage, but then also speed up the query performance, because when you have less data on disk, you have to query less data from disk. That's the basic idea. So there's a lot of arguments why we have a delta check when loading the satellites. Now think about this. In CDC, you don't receive full loads. You're actually getting the opposite. You get deltas, right? However, the only thing, so this argument that you have to remove a lot of non-deltas isn't there yet, right? Because you're receiving deltas, not non-deltas. That's number one. But then on the other hand, when we think about this, in CDC, you receive a delta whenever there's a change in the source table. And it's different actually to the delta check in a satellite. Because think about this, when you have, let's say you have a white table, hundreds of attributes in the source, we often split a satellite, and there's many reasons why we split satellites, right? Security, privacy, source system, rate of change, and so on. Different reasons why we split a satellite. And the idea is that when you have a white source table, when you split the satellite, and only one attribute was affected in the source system, that triggered the delta. That's why you get notified by the CDC application. There's a change. Only one attribute was modified. The only satellite that would capture a delta is the one satellite that stores this one attribute. The other satellites wouldn't be affected, right? So the target-driven delta check of the raw data vault is more efficient than the source-driven delta check of the CDC approach. That's your first observation. So does it sound worthwhile to spend a lot of time and dealing with the delta check in CDC data for capturing all these changes? Not really. Because yes, it's more efficient, but not that much, to be honest, right? So what we do in CDC is we offload all the changes from the incoming deltas into all the target satellites. We just turn off the delta check. That makes it much easier to absorb these changes. Now the only thing is, how do we capture multiple changes in the same mini batch? Let's say you get the data in near real time into a data lake. There might be multiple changes on the same account in the same CDC batch. How do we capture this? We don't use a standard satellite because it wouldn't be able to capture multiple changes on the same load data timestamp for the same hash key. That's a primary key, you get a primary key validation. We don't use multi-data satellites because these changes haven't been active at the same time. So what we do is we create essentially a satellite where we increase the load date by a microsecond or a nanosecond, change by change. So all these changes are in the right order according to the CDC package, in the same order as in the CDC package, but on the load date timestamp, they go forward a little bit step by step, delta by delta essentially. Remember, the load date timestamp is only giving you the technical timeline, so it doesn't indicate when the record has been modified or has been changed in the source for real, right? So that's some other timestamp. The load date is just used for absorbing the data into the database, and that's why it works. And then the cool thing is now the latest record from the CDC has the highest load date, and that means that we can just use our standard practices downstream to get the latest delta for your accounts. So that's the approach how we capture CDC data. We turn off the delta check. And it doesn't matter if it comes in real time, for example. Now the other thing for real time is, are we capturing accounts in the first step? And remember, for the data warehouse, for the enterprise data warehouse model, or the integrated layer, the idea is that we have two layers here. We have the raw data vault and the business vault. And the purpose of the raw data vault is to capture the raw data in the first place, integrate by the business keys, and historize them. That's it. You historize this data. But we don't apply any business logic. We don't interpret the data, nothing, right? So that's all done in the business vault. So it's a two-step process to come up with the final enterprise model that reflects your actual data and the way how you want to use it. So you don't, just like in traditional data warehousing, we try to do everything at once. We came up with a integrated model essentially at once, and that's essentially reducing the flexibility of your model. You can't apply different business perspectives on the same data and so on, or you limit it at least. So it's a two-step process. And in the first step, you have to absorb the data, but you don't get account data actually. In the first place, what you get is messages. You get real-time messages, right, from Kafka. And the best or easiest model to capture these messages is a non-historized link. I mean, the transactional link was renamed into non-historized link because a transactional link is not only used for capturing like booking transactions in the bank, but also messages and events. So the non-historized link is the typical design or typical model how we capture real-time messages. And that's what you're receiving. You're receiving real-time messages about changes on the account record. That's what you're receiving actually in the first place. That's your raw data. So what I would do is this, and that's what was my recommendation. I would always capture this data or these messages in the first step in a raw data vault as non-historized links. It's maybe not the nicest model, but it's super easy to load them because then you just capture the data as it comes in into the raw data vault. It's super easy to load because you're just inserting those messages as rows into the non-historized link table that you're done. Maybe you have a non-historized satellite on top of that, but that's more or less it. Because they had some challenges there, late arriving messages, they didn't came in the right order and so on. So yeah, good luck when you try to apply delta check. They must be in the right order, right? Because otherwise you don't know what was the state before my current change, what was the previous version of the same account. You don't have that, and that's a killer. So, but if it's just messages, you just dump them in. You attach the load date when you receive the message in a raw data vault. You attach all the other timers you have, maybe a message timestamp from the message queue or message topic, maybe some timelines from the source, maybe an updated ad or something, right? So you just offload everything to the nonsense link and you're done. If they come in a different order, who cares? Not the nonsense link. It's only there for capturing these messages. So easy to insert the messages into the raw data vault in the first place. And then if you want to have a more business-friendly model where you have a account hub and a satellite for the accounts, we could do this in the business vault virtually. Because, I mean, first of all, I would have an account hub anyway, also in a raw data vault, right? Because there are messages with business keys. There's an account key inside your message that describes the update, right? So I can extract those business keys into a hub in the raw data vault in the first place. So I have the hub accounts, I have the message, the non-historized link for the message about your update on the account, and maybe a non-historized satellite attached onto the non-historized link. And then everything else would be done in the business vault, and that's actually easy. You could easily transform a non-historized link into a satellite by using a view, because you have everything already. You have the hash keys, you have the load dates, the descriptive data, everything is somewhere in your raw data vault, either in the non-historized link or in the non-historized satellite essentially. So we can just have a view on top where we present this non-historized link as a satellite, but without any delta checks. Makes no sense to apply delta checks here, by the way, because you already stored the data. So you can't read, I mean, why would you store the same data again, right? So not worth it. Especially because the argument that we would like to remove maybe some non-deltas doesn't hold true either, because first of all, yes, it's still already delta-driven, so yes, you might save some storage by applying an additional delta check, but then who cares? Because not your users. Users wouldn't care. Because in the end, what happens next is you will introduce a PRT table where you essentially create an index that identifies for every account what's the latest delta in a satellite. Well, here we're talking about messages about your account. So the question is, what's your latest message about your account? One of these messages in a non-historized link. And that I can build already with the non-historized link. So having a materialized satellite in between only consumes more storage. Why should I do that, right? So that's the idea. Once you have the PRT table, then you can build a view on top and present the data as a dimension for accounts, for example. Relatively easy design. So not the nicest model, but it's not the nicest model, but it's really the most efficient one when you think about organizing the data flows from the real-time feed with the CDC data all the way through the model, integrate everything, historize everything, and into your dimensions. The most efficient model in that sense. Easy to load, easy to consume, fast like crazy, not very complex, actually very simple. So that's what it is. So that's what we typically use for processing real-time data, but even CDC data via real-time. I tend to have these models essentially. So that was the discussion essentially with the client. There are some interesting aspects here. Let me just go here. When we talk about architectures, we often see the Lambda architecture in the industry versus the Data 2 architecture. Well, not many people compare it, although. So in the Lambda architecture, you have essentially the idea that there's two streams. One is the more batch-driven stream where we where we essentially spend more time on cleansing data and making it right and so on. Right? We have more time for processing the batch. That's the idea, and that's where we clean it. And then you have the real-time feed, where the goal is really to push the data as quick as possible through, so we might not apply as much business logic as in a batch and so on. And then we combine it on the information level. At least that's the theory, right? So we combine on the information level, where we combine the results from batch, maybe the more sophisticated data, and then the quick data from the fast lane, or what's it called, in the information layer at the end. While in the Data 2.0 architecture, we absorb the real-time messages from the message topic or queue directly into the raw data vault in the first step. So we take the message, break it apart, just like any other source table. It contains business keys, relationships, and descriptive data. We break it apart, load it into hub-sync satellites, and then we pick it up again and recombine it with results from the business logic, from the business vault, combine it and maybe produce new real-time messages enriched by results from your business logic, enriched by other data, and so on. But we absorb it early on and then produce real-time results just by querying it, for example, querying it from the platform. So there's a slight, there's actually a big difference, at least in theory, because in practice, a lot of people who use the Lambda architecture, they also do an early integration, and they also apply complex business logic sometimes if it's required in a real-time feed and so on. So the integration happens much earlier typically. But that's the theory at least. We do a early integration on the raw data, and then the information is just based on real-time data and or batch data. Nobody stops you from using real-time data in your daily reports, which are produced by batches or in batches later on. And nobody stops you from using your data that comes in batches overnight to enrich your real-time messages. Why not? I mean, that's absolutely fine. So that's what we do all the time in real time. There's an interesting article that we wrote again. 1 second, I have to get it on the right screen here. That we wrote essentially for a blog at Microsoft. 1 second, where's my screen? That deals with the real-time processing and has a description of these architectures. It's an architectural article, so it deals more with architectures, less with modeling. I don't believe it covers, let me just double check. It doesn't cover how we model real-time data. Like the CDC discussion I just had with you guys, we don't cover it here. But it covers the different architectures. So we have the Lambda architecture here, speed layer and batch layer, that's how we call it. And then we have a serving layer, that's essentially the information layer, where we then combine those aspects essentially. While in the data vault architecture, we combine early on, right? So we absorb these real-time messages directly into the raw data vault and also fork it into the data lake for the data scientists so they can use those real-time messages as well. And then we typically have a series. So think about this. In a data vault architecture, you have multiple layers, right? So you have a data lake, you have a raw data vault, business vault, information vault. And the same you want to have in real time. Because when you process data in real time, there is typically a message queue that captures the data coming from the source system. That's at least would be the best design because then I can distribute the workload to multiple subscribers. And the subscriber here would be what we call the raw data vault loader that picks up the message and essentially breaks it apart into business keys, relationships, descriptive data, and then loads the data into the raw data vault as insert statements or whatever. So that's a raw data vault loader. And if this is a message queue, I can have multiple nodes, and the message queue would then essentially distribute the messages to individual nodes here, worker roles, and they will essentially process the data. That's why we prefer a message queue here. And once the raw data loader is done, you might want to consume the real-time feed, right? But there must be you want to also apply some business rules. So we put that on another message queue again. So the same message as we received it, we put into 3 locations. We break it apart for the raw data vault, we keep the original structure for the data lake, and we keep the original structure and push it forward to the next message queue. And then you have a business vault processor. Sounds big, could be big, you could have some business logic in there, but most of the business logic we just apply in the business vault. Remember, your real-time feed is now in the raw data vault, and it gets updated in real time, right? So when there's a new message, you just push into the raw data vault. So these tables where this raw data vault loader inserts messages to is in real time. These tables get updated in real time, right? So when you attach a view on top, this view is also in real time. Whenever you query, you have some new data in there, right? So that's the most easiest way to implement business logic in real time. Just attach it to the business vault attach it to your real time enabled raw data vault entities, and those views will be real time as well. And then the business vault processor, what it does is the goal of the business vault processor is essentially to produce the outgoing messages, right? You could also call this information processor, whatever, but that's what it is. So there's this business vault processor essentially picks up the data. First of all, it gets a trigger event, the incoming message from here, from the raw data vault loader. The raw data vault loader essentially notifies the business vault processor there's some new raw data, and you might want to act on that. So it receives the incoming message. It has the raw data already, but then it can join other data as well. It can join data from the raw data vault, other data from the raw data vault. It can join data from results from the business vault, and then pushes out the message to the outgoing topic, and the message topic then distributes the same message, to all the subscribers, to real-time dashboards, to applications, and so on. And they can also consume additional information from information marts typically. Now you could argue, why don't we just produce a full information mart message, the full information message here, and push it via message topic to the subscribers? There's typically a limit on how large this message can become. So on large data sets, and the other thing is, on a dashboard, you want to, depending a bit on the dashboard implementation, but on a dashboard, you want to have a line chart where you see the last 60 seconds or something of your KPI. Sometimes these dashboards keep it for you, but what about late arriving measure values, right? When they have an impact on the KPI computation. So I want to also adjust my KPI values, which are shown real time as well in real time. So what we typically do is there's a demand by the tools to get more information that fits into your message on the topic, because there's typically a limit on how large these messages can become. And as soon as you start adding 60 seconds or 5 minutes of information for a chart, or maybe some more complex information there, you might get a problem in hitting those limits essentially. And again, it also depends on your technology you're using and so on, right? So what we typically do is, if there's need for more, this message that's being sent out here is in a most simple case a notification message. Hey dashboard, there's something new, something happened in my data warehouse here. I calculate something new for you, pick it up. That's the most simple message. If I can, I'm also adding the information itself. If it doesn't exceed, or if there's no risk to exceed the storage or the size of this message limit essentially. So I'm notifying the dashboard something is new, and then the dashboard will act on this incoming message and query for more information. That's the basic idea. So it picks up more information from the information marts and displays then the results in the dashboard. That's the basic idea. Again, in real time, you want to push forward. You don't want to wait a couple minutes to query again, like in a dashboard, to query the results from the data warehouse every 5 minutes or something, or every second. No, you push, you notify all the time, and every layer notifies the next layer something is new. We push the message forward. Real time doesn't say that you have to get this done in a couple of seconds. It could take hours to calculate the business logic, because super complex business logic, well, it shouldn't take hours to be honest, but it can take hours. It's still a real-time system, because it takes hours to calculate business logic and to produce something. So there's no time limit on how fast you process this, at least in the first theory, initially, and you just push it forward. There are, though, some requirements how fast you must produce these results. There might be time limits here involved. That's the other story. But yeah, but in theory, there's no time limit. You just push it forward. But you notify the next layer all the time. So everybody gets notified and acts on your notification that something happened and I have to do something now. That's the basic idea. That's the architecture-wise. That's how we set this up essentially. Super interesting stuff. And again, virtualization here helps you to simplify the processing of the real-time messages, right? If everything is virtualized, your views are virtualized as well. So worth a read, in my opinion. A bit older article, maybe a year or 2 years old now. I'm not so sure. It's 2 years already. So not yet. So there's 3 more days and it's 2 years old. But yeah, it's in my opinion a good read essentially. I wrote it, but well, not me alone, but it's Ole and others. But yeah, cool. I think it's a good discussion. We discussed the CDC data already. We discussed master data via real time. I mean, if it's a transaction you receive via the message topic or via real time, that's typically easy and obvious. Transactions, most clients, they store these as non-user links anyway. But even master data via real time, most clients get CDC data via Kafka then. I would store the CDC messages as events first, and then turn them into if required at all, into a more readable satellite, just to have them included in the pit table essentially. That's a nice trade-off between high efficiency, nice design in the business world, and then easy information delivery essentially, easy application of business rules and so on. So that's what there was a discussion we had essentially with the client. Good discussion. So that's changed a bit of their current model, I believe. I hope at least. And then So that's one thing. Real-time Flow BI, it's also a topic of mine, right? So also consumes a lot of my time essentially. Actually, typically my night shift. So during the day I work for Scalefree mostly. In the night, when the kids are in bed and so on, I'll essentially start working with Flow BI. The idea is that in Flow BI we also support real-time, but it's a bit different. So what Flow BI does is it is a Gen AI for your data vault, right? So it looks at your data and then comes up with a model to capture your data in a raw data vault. Comes up with all the hub sync satellites, the satellite splits, the business keys, and so on. But real-time in the first place is an implementation topic. How do we process these real-time feeds? What kind of tools are we using to get the data from the message topic into the raw data vault? How do we apply business rules and so on? Because the message itself contains data, and data always contains business keys, relationships, and descriptive data. So what Flow BI does is, well, it not yet, but it will be there because it's relatively simple for us. We use a JDBC driver to connect to all the data sources. That's our standard approach. And there are JDBC drivers available for certain message topics or message queues, including Kafka. So our job would be to use to look at your messages and identify the internal structures inside your messages, inside your JSONs. And then if you, and that's under your control, if you declare those message topics as non-historical, then it would first of all make a decision most probably to go for non-historical links and break down the messages into the individual components, into the business keys, relationships, and descriptive data, and then come up with a data model for your raw data vault. So it will indicate how do you break down the incoming message structure into the raw data vault's hub sync satellites. That's the purpose of Flow BI. And then it hands it over, this logical model, these definitions, as metadata to the tool of your choice for database automation. And then you have to have a tool that's able to essentially process these real-time feeds, implement those real-time feeds, right? Many tools, they don't support that. Many tools don't support that, let's say that. But what we do typically, we often build our real-time processes manually using Python scripts. That's what we do a lot. So you could consume the metadata from Flow BI and then use that metadata so you know how to break down how do you need to model the raw data vault. You get to create table statements, but you also see the data flow from where in the message you have to push this into the raw data vault essentially. That's the idea. And if you have a mixed, let's say a message topic with mixed message structures, there's no clear JSON for all the messages, right? So every message is different. High chance that it would go for a JSON structure, because there's no better. So so that's the idea inside Flow BI essentially here, how we process it. It's not a big concern for us. We are more interested in the structure of your data inside the messages. That's more of a concern for us, and then produce the raw data essentially for that. If you have any questions, just send them here on the chat, right? So in your tool, you should be able to send in your questions. I know that you can only send them, I believe, on YouTube, because I know that on last time we had some questions on LinkedIn. Let me just double check this. We had some questions on LinkedIn and they didn't show up here on my screen here essentially. So let me just go into LinkedIn and see if I can see any questions from your side. That's you can only that's send not them, good. I believe, on YouTube. That's not good. Okay, so it's an echo. Okay, so I can't go to LinkedIn as well. Okay, so yeah, send them into YouTube. That's where you send. That's where you essentially get these questions on my screen. Essentially, that's maybe the better option essentially for you if you want to ask questions. Go to our Scalefree.com YouTube channel. On the live tab, you see the live session here today. Okay, because then I can pick up your question and show them on your on the screen as well. Okay, so that's the real-time section here. Speaking of Flow BI, I did a lot of Gen AI this week for all the reasons. First of all, I have a terminal that I'm using, and I'm using a different terminal which is called Warp, and Warp is essentially it's a different terminal. I mean, the reason I'm using macOS or Apple MacBooks is because when I came over from Linux, I was looking for a more user-friendly Linux and with commercial applications, and that's where you naturally end up with macOS essentially. At least back then. 2009. And then I really wanted my shell. That's what it is. So that's why I ended up on Mac essentially. I get it. So you have a shell these days on Windows systems as well, much more. So you can use these commands from Linux, I believe. But it's they came too late with that. That's what it is. So and on Linux I'm using Warp, which is essentially sorry, on macOS I'm using a different shell, essentially Warp, which always they had some nice features. I'd say that. So that's why I went for it. Bit more complex shell, but very user friendly as well. So it's an interesting shell essentially. And they also include now essentially the LLMs essentially, like the Geminis or what else you want to use. And yeah, let me just show you the video. It's actually quite interesting. I hope the audio will work. Let me just double check that. Should. Yeah, it should work. So let me just show it to you guys.
Keynote 2.
Okay, 1 second. I'll get it up here. It's a release video. I'm not promoting tools here. I don't make any money with it. So it's just an interesting tool, and they got some interesting spin how to show this essentially, or how to integrate the LLM essentially. So I have to switch to a different codec. I just realized that you might have not heard me. Uh-oh. Let's see how it goes. Okay, so that could be a bummer, because I just realized I didn't switch the video stream back. I had a good discussion here. Maybe I repeat that next week again. I'll check out the recording. Cool, thanks for joining. That will be a bummer. Thanks, guys. We'll see.